Hello. Hi, Andrea.
I say.
Hey, hi, how are you? We're live on the television.
We are live. Okay.
Okay.
I'll try to abstain from saying things that will be permanent.
Yeah. So, how are you doing?
Oh, I'm fine, thank you.
Yeah, I'm good. So it's a nice weather here.
Lucky you. We've been here. It's been raining since 3 days right now.
Okay.
Pretty cold.
Okay.
And I've been yesterday to my cabin in the mountain. It
Oh, nice.
was freezing cold and very foggy, not very pleasant, but I had a good sleep, and that was really nice.
Okay. What I was gonna say? Yeah. So you were asking why we tried to do the Jitsi last time.
Yeah.
But what I noticed is that I did not notice it during the meeting, but I watched the recording later on. I noticed that it appeared as if people talking to me, but I couldn't hear them, and I just keep talking, and it was a bit weird because it looks like I'm ignoring everybody. And I think the reason for that is because the latency was so high, and I just wasn't catching. I mean, yeah, it looked pretty weird. So I'm trying to see if Zoom would be better, and that's why I tried this. And I realized that there is also so this is the pro account, but there is also a what's it called, the business account, which gives you this kind of I think it gives you some extra things like domain name or something like that.
Okay, so you solved the issue about the same account you have to get.
No, I just got another one. So I just bought the 2 subscription. I don't know. I think I might need to cancel the first one because now I have 2. Because I think I could have played it with it a bit more. Because in Zoom you can set up to so there's a permissions, and so there's a permission to stream it to YouTube, but then I think it assumes that you have the same account for YouTube and for Zoom. But then there's another one, which is any custom streaming services, and I think YouTube could do as well, but I didn't figure it out. I just wanted things to work, and just throw more money at the problem.
Okay.
Okay, so yeah, when we so I guess we're a bit 8 minutes late, 8 minutes earlier, but I guess maybe some people will join us a bit later on. So far, I saw that our announcement was received quite some attention, I suppose. And I since I've written the announcement, I just realized there were other benefits of doing this, what we're doing, this Erigon one, and this is basically to to give ourselves a little bit of a break from supporting this ever-changing code, because one of the things which kind of was a bit stressful is that when we're trying to keep the releases stable, but at the same time we keep changing them, and then we do inadvertently introduce problems, right? And then people come up with the new issues, and it's just a bit you just want a bit of break from it for some time. So I think what I hope that we could do is that as we stop touching that Erigon 1 code,
it helps draw a line and say, okay, new features eventually will be available in the version 2, whilst we keep working on stability of Erigon 1. And so this is also, I think, a good chance for external developers building some kind of apps on top of Erigon to choose whether to continue chasing the newest feature on the Erigon 2 or stick with what Erigon 1 has to offer right now.
Right. Okay. Yeah. And another thing that I another thing I thought about it when I was trying to write the announcement in describing what sort of plans we have for Erigon 2, and I was about to be carried away because you know what mistakes that I did before, and I mean other people did before, is that you have a lot of ideas about what your product should have, but obviously there's not enough time and to implement them all. So you implement some of them, and then you say, okay, I haven't managed to implement all of this, so let's roll it over to the next thing, right? And then you come up with the version 2, which already has a huge list of things in its scope, and then you know for sure that this is not going to happen, right? Even with the version 2. And if it's too long, then okay, then you're going to develop version 2 for another year or two, which is kind of a bad thing because you have to maintain 2 versions for a very long time. So what I figured instead, I stopped myself. I said, okay, well, I list the 3 things that we want to do, and then stop here. Because the other things that we might want to do, we're probably not going to, we want to do the important thing and then stop ourselves and say, okay, this is version 2. Now we're going to make it through the alpha into the beta, at which point we're probably going to start cutting support for version 1 and so forth, so that we don't really want to, keep this process relatively agile, but still kind of relatively stable, and give ourselves the chance to, once in a while to experience this freedom. I think this is one of the things that a lot of people in the kind of core developers complain, that once you build the product and people start using it, you kind of restrict yourself, you kind of put yourself in the chains, right? That, and then eventually they just kind of jealous to the people who are, okay, we don't have that constraints. Like when I first started TurboGeth, I said, wow, great, I can change everything. I can change this, I can change that, and I don't care. But then I think it's still possible to give yourself this freedom once in a while, with these transitions. And luckily as well that I hope that in Erigon 2, it will be even quicker and easier to sync Erigon. So I think one thing which really is really important is that how quickly you can, iterate. Like one of the things actually, when I was thinking about it, I remember who I talk about it. So the stage sync, right? The introduction of the stage sync was kind of a last minute decision back in 2020. Now I think it was the totally right thing to do, because it allowed us to iterate over the course of 2020. It allowed us to iterate much faster than we would have done, because back then, before we introduced the stage sync, the full sync would still have taken 2 weeks at least. But with the stage sync, we pushed a bit further, and it took about 2 days. So it's a huge difference whether you can iterate over 2 days or over 2 weeks. I think it sort of was that totally right. And then I hope that with Erigon 2, we will keep it in mind that you need to be able to iterate really fast to develop.
And also, as this also gives us the Erigon ecosystem gives us more freedom in choosing whether or not to break something, because the cost of a sync from scratch is decreasing and decreasing. So eventually long migrations are no longer needed, and it helps us to not be handcuffed to some specific usage, because we can break things, make it better, and and we are more free to ask our customers, let's call them customers, our user base, to resync from scratch, which is not a big deal if it's
Yeah.
only a couple of days.
Yeah.
2 or 3 days.
Good. Okay. So that was my some of my initial thoughts. Let me check how we're doing on YouTube because I'm kind of curious how it's going. Okay, so we have some delays, which is actually, I think Zoom introduces 30 seconds delays or something. Okay, so Artem is here. Hi, Artem.
Hi, Artem.
Hey.
So we are live. So actually, now we should see. Somebody was mentioning about the view. We can play with it right now. So I could see on YouTube now. Artem has not joined yet.
Yes, I think we have a 30 seconds delay on.
Yeah, so I just want to see.
Streaming.
Somebody was asking me last time about changing the view, how we could see everybody on the same screen or something. I just wonder
yes,
if
it was me. If you can switch the tile view or the.
Okay, so I have a gallery, immersive speaker. So the gallery is probably what we want, but for some reason the YouTube does not show Artem. Maybe because he doesn't have a video. I think it doesn't show the people without the video or something.
It should.
Maybe there's some settings about this.
I try to deactivate my camera to see if I disappear.
Okay, yeah, try to see if you are gonna disappear on YouTube.
Okay, I'm off.
Okay, you're off. Let me just wait 30 seconds.
Okay, now I see.
Yes, you have disappeared. Yes, I think it's true that. Okay, I think we probably can go on with that. So it's actually okay. I think Zoom has probably figured out that, there's no point showing the empty boxes on or boxes with the names.
But
Okay.
I think it's useful to see the highlight box of people speaking instead of streaming their video.
You mean like
in the dev calls, when you have the tile view of all the participants, some of them do not have the camera on, but you still can see that they are talking because their tile is highlighted.
Okay, well, you know what? I'm gonna do this. There's this. Let's see. There's an art gallery view. Do you see it?
Oh no, it's still loading. Wrapping view. Oh, okay.
Yeah, I wonder if YouTube is going to show the art gallery in 30 seconds. Let me see. And then I can show you the other bits. I think there's also bedroom view and the classroom view. Okay, we'll check. Wait. Oh, this is quite annoying, this delay. So I'm gonna try the.
I think the art view is not showing properly on the screen.
Okay, so it's probably that's showing the one person, right? Anyway. Oh no, it's actually. No, yeah. So the immersive view only shows in Zoom itself, but not on the live stream. Okay, fine. So I'm gonna switch it off. I'm gonna switch back to the. Yeah, I only say. Stop immersive view. So maybe there is a setting for the view to show people even if they don't have the pictures. Let me check. There must be some preferences in there.
Well, I see now on the Zoom app. If you click the view in the upper right corner,
yes,
and you have the gallery view.
Yeah. And that's what I kind of have. What is this? What I have turned on.
I see the tile also of Artem, but I don't see it yet on the stream.
Yeah, I think it filters out when it sends the stream on YouTube. It actually removes those people who don't have the cameras on, and I think there might be settings for that, but I can't find it right now. So it will be good.
Do that. If you click on the ellipsis on Artem's tile,
Yeah.
you see that you have the third option is show participants without video.
Show without video. You mean more?
Oh, now I've lost Artem. Oh, yeah.
No, he's still there, but it's show participant without video. I actually don't really see where this option is. Okay. Oh yeah, I mean, I think I need to search for it. It's going to be my homework for the next time. To try to do that.
Because otherwise, it's almost impossible to understand who's talking.
Yeah, it's true. Yeah. So now Alex is here. Okay. Hi, Alex. I think I need to search for it. Oh, like, okay, so now you're gonna be you know you're gonna be eating your apple on the YouTube live stream, right? You know that.
I think she's doing on purpose.
Okay. Yes. Okay, cool. Yeah, so I don't know. I mean, I think I need to just check for the settings. I'm probably not going to do it right now. So at the moment, we only show on a live stream only the people who are who have their cameras on. We don't show the people who have no cameras on. Okay. Cool. I think we can start the official part of this talk. Well, it's not going to be a talk. It's actually going to be a discussion about Erigon Beta and Erigon 2. And I thought we could talk about, I mean, I think everybody probably understands what the beta is, right? What the beta is going to be. So I tried to describe it in that announcement. So it's basically just the fact that we're going to make beta releases of the stable branch, and we will continue development in the Devil branch, but the stable branch will not be updated with everything from the Devil branch every week, but instead we only going to put 4 types of changes in the stable branch, and I think I listed them. And these 4 types of changes are, just a second, I remind myself. 4 types of bug fixes, right? If we find the bug fix, missing features, that's mostly for RPC requests, because we know we still have some missing things. And then the optimizations for skip analysis and the pre-verified block hashes. So these are 4 things that we can. And of course, I also then realized that, I mean, I specifically wrote that we're not going to try to do optimizations, but we might need to do something if we find that certain things are super slow and then they shouldn't be. At the moment, I'm not aware of the very serious performance regressions, or so I don't think we're going to be doing this. And what we could talk about is that I suggest these topics. What is going to be in Erigon 2? When do we think we're going to close Erigon 2 to go to alpha? How are we going to do the merge? And basically, yeah, that's the questions we can discuss. Anything else?
I think it's too early to answer these questions, at least not until you finish your work on researching the state sync and the new state storage, basically.
Well, I think we could probably at least talk about what this research is, and to start sharing this understanding, so that when I'm really glad that Alex started to look into some of these things with me. So in particular, he's working on experiments with the block bodies that I started myself, and then now he's adding the indices to them. And depending on how we go, it might be that we're going to start introducing this features into the Erigon 2 before the state sync. And that's actually, I mentioned this particular experiment in the list and the announcement. But for the state sync, yeah, essentially it's a kind of it probably will be the main starting, so the main starting feature of the Erigon 2, and state sync based on these files. So we're currently having the state being represented as a table in a database which contains this entire state. So somebody is just asking something. What is it? Oh, I mean, Andre, yeah, if you want, I think he's away on the Discord. So yeah, the kind of the idea is to push most of the state out of the database and into these large files that will have a compression, some kind of search capabilities. And when the files are big enough, we will be sharing them across the network. And also something that I actually realized just today, because I'm trying to prototype this particular way of syncing. You probably remember that we have the notion of change sets at the moment, right? And the change sets currently play the dual role. So they're being created every time we execute the block inside the execution stage. We essentially create a change set, which is currently like a list of all the changes that happened during this block execution and so forth. But when we record those changes, the values are the previous values of the items, not the updated values. So it's actually not the value after, it's value before. And so we use these things for two purposes. First of all, we use them for executing the unwind, where we aggregate them and play them back in reverse order. And secondly, we use them as the kind of the carrier of the history of the state. So what I realized today when I was trying to do it in the sort of Erigon two way, I also needed some kind of change sets. But first of all, the functions will be separate. So there will be separate change sets just for the unwinding, and the separate change set just for the history. These two functions will be separated. And secondly, the change sets that are for unwinding, they will not be written into the database. So essentially, they will be written into files, but not like one file per block, which is going to be too many files, right? Instead, what I figured out, what we could do is that we will be opening the file for writing, and we keep appending the change sets as we actually right now doing in the database anyway. We're doing append. So if the unwind happens, all you do is basically you just truncate, and then you can append again, right, from the point where you're truncated. So essentially, these files are moving like that. But these files are also cut off. So essentially, so let's say that we could choose some constant, let's say 4,000 blocks or 8,000 blocks. So once we have 4,000 blocks of this change set, we do cut off. We basically close the file. We open a new one, and so we get another file of this change sets and so forth. And obviously, we can go backwards as well when we unwind. So what's the purpose of these files? Well, these files help us unwind, but also once we get to the what we call the immutability threshold, or we call it unwind limit. So it's, let's say currently it's 90. Oh, Andre. Hi, Andre. So currently it's 90,000 blocks. So what we do after this, we'll say, okay, the unwinds won't happen anymore. So we just take these files. Hi, Andre.
Hi.
You're on the live stream, by the way.
All right.
So you're on so I have to warn everybody, so that unless you're not, just in case you're not aware. So basically, these files, the change set files, will be on the background, will be aggregated into larger files and larger files and larger files. What it will mean is that the amount of data in a database was actually going to be much smaller, I hope. And I haven't done experiments yet, but I'm super excited. Hopefully, do something about it this week and give you some updates. but yeah, so it's enough, of course, the performance numbers as well. And yeah, Andre, we've just been discussing the kind of the new state sync, which is kind of the foundation for the Erigon 2.
And you used a fancy algorithm, right? Rec split or something.
Oh yeah, the fancy algorithms are basically the building blocks for, and we can talk about fancy algorithms if it's interesting. So there are two, actually maybe 2 or 3 building blocks that I have created, and now Alex is working with them as well, which I'm really happy about. So the first building block, yes, is the rec split, which is the recursive split algorithm for creating what they call minimal perfect hash functions. And we're using them in multiple places. I think we're going to be using them in multiple places. So what it allows you to do is that it allows you to map a certain set of keys into a set of numbers from 1 to n, where n is the number of keys, and such that there's no collisions, and that allows you to essentially without pretty much any waste of space to create this mapping. And so we're going to be using them for all sorts of indexing, only in the situations where we either sure that that the keys that we're querying for are in the set, or we can check later on that, you know, if the key matches on or not. That's the first building block. And there were a couple of more building blocks. For example, there is the compression decompression mechanism, which is building blocks for compressing those large files. And I have published the table, which basically interestingly, so how much could we compress the different parts of state and the block bodies and so forth. And let me just remind myself about what were the compression rates. I think the block bodies compress at about 40%. By 40%, what I mean is that if you take the initial uncompressed size, you subtract the compressed size and you divide it by uncompressed size. So it's actually by how much did the size reduce. So on average, the block body is reduced by 40%. The state accounts reduce by 4%. The state storage by 33%, and the code by 83%, which is kind of actually what you would expect, because accounts there isn't not much to compress there, because their keys are pretty much random, pseudo-random numbers, and there is a little bit of compression happening in the values, but not much. For the storage, the reason why compression works is there's a, you know, what I'm actually compressing is a representation where the key is a combination of address and the location. So the address is repeated many times. So if you have contracts with a lot of storage, obviously that's repetition, and that's why they compressed 30. Well, it basically removes 33% of those, mostly those prefixes, and I think you get pretty much the same compression if you simply put it into the dup sort table in MDBX, because it does exactly that. It just removes this prefixes. And for the code, and of course there are lots of repeated snippets in the code, and that's why there's a pretty good compression, minus 83%, because you would expect the code having lots of there's lots of contracts having the same code or same snippets of the code and so forth, because the compression method we use is not is actually pretty general. It could look it looks not just as a prefixes, but it looks inside the words for patterns. So if there's the same pattern in the middle of the code or in the middle of the key or any value, it will still try to compress it. But yeah, and another interesting thing about this particular compression, why did not I take any other already existing compression mechanism, is because what I really wanted is that I wanted to have the access to the data, by the key, without having to decompress large amounts of data. So essentially, if I had just do this LZ77 or something, so I'd need to sort of split the data in the chunks, and then you say, okay, if the key is inside this chunk, I need to decompress this chunk and then take the key. So that's quite wasteful. So in my scheme, you can decompress just a specific word, just a specific key, and then specific value. And now we're using these building blocks for, we actually probably going to experiment with using these building blocks for quite a few things. Yeah, for the state, for the block bodies, but also for the change sets and other things as well. And I have yeah.
Cool.
Okay, so.
Actually, today I ran this compression comparison with the default LZ4 CLI tool in Linux, and actually your compressing better, has higher compression ratio than default LZ4. With something like LZ4 -4, it's starting to be better.
Oh, okay, I see. I mean, the thing about the LZ4, I'm assuming that basically a lot of these compression mechanisms are based on the basically building a dictionary, which is what kind of patterns you're going to be looking for and replacing, and then replacing those patterns with some code words, right, for these patterns. And that's exactly what our compression does. But it's building the dictionary as the kind of the first pass. It has this compression basically has 3 passes over the data. So in the first pass, it looks at everything and tries to build the initial dictionary, which is limited to about 1 million different patterns. So what it does, it tries to find the substreams that are most present in all the words. It sorts them in this order, and then it selects about 1 million of the most frequently used subwords, and it basically it sorts them by what I call the score. And the score is essentially a product of how many times this pattern is present and the length of the pattern. Essentially, that's how much potential compression this pattern can introduce. So then I take this 1 million words, so 1 million patterns, and then I start a second pass. And in the second pass, what I do is that I look at each word and I try to find which patterns exist inside this word. And then I run the optimization, trying to see what combination of patterns will give me the best coverage, of this word, including the situations where patterns can overlap. So essentially, that actually was a great simplification of this thing, is that I allowed the patterns to overlap within with the words, and that led me to because if I didn't allow this, this optimization problem will be NP hard. But I managed to, by overlapping, I actually reduced it to the problem which could be solved by dynamic programming, which is n cube, and it is currently solving it with dynamic programming. It figures out the optimal set of patterns, and then records that set of patterns. Then on the third, so of course, after the second phase, it knows which patterns have been used, and it calculates their frequencies. And then it says, okay, I now need to use the Huffman algorithm to find the code words for these patterns, because it says the patterns are used the most need to have a shorter code words, depending on the entropy. And essentially, I build a Huffman tree, and then I figure out the code words. And then I do the third pass, where I already knowing which patterns I've used before, but now using the computed code words from the Huffman tree and just replace them. And so in the end, the compressed file is essentially the Huffman tree, which allows me to decode any basically code word into the pattern, and followed by all the words, but where the patterns are replaced by the code words, essentially, and that's it. And of course, for this is not enough, because if you want to use this file as the key value pairs thing, you also need to find for each key, where does it start inside the file? Like, you know, because all the keys and values have different sizes, especially when they're compressed. So essentially each key and value has an offset. So then you have to have an index, which allows you to find this offset by, you know, key. And this is where the perfect hash function comes in. So in our case, in a state, there will be, we first go into perfect hash function. We say, okay, for this particular key, what would be the offset? What would be the index? And then you get, okay, here's the index. We look at the offset and we go into this offset. We decompress specific key and a value, and we check, is this the key that we expected? And if yes, then we get the hit. And if no, then we go to another file, something like this. Yeah. So we just, before you guys joined, we were talking a bit about some of the realizations that I had after after I started writing this Erigon 1 announcement. And it's kind of this a bit of a meta discussion about, first of all, I realized that it's an interesting thing because it will allow us to have a bit of time after we've done a beta to have more free experimentation, as I say, with the data model to move a bit faster, because initially we won't even need to do data migration until we say that Erigon 2 is an alpha. I'm not sure how long this is going to take, but it's sort of, I want to have this kind of a bit of a time where we take a break from continuously, introducing problems and solving them in our code base, but instead just, introducing problems for the users. Not for ourselves. But then the second thing I noticed is that when I was trying to describe our plans for Erigon 2, I had to cut myself after like 4 items, because I realized that I don't want to roll over everything that we thought about that we could do in Erigon. There was a huge list, and I know that for sure we're not going to be able to do it in Erigon 1. Then instead of trying to roll it over to Erigon 2, and also knowing, okay, there's no way we're going to implement these things. And also I say, okay, let's cut the scope. Let's make it small. And so far, I think I listed only 4 things in the scope, because if we make the scope small, we can try to deliver Erigon 2 alpha as soon as possible. And that means that we're going to start preparing it for the beta. And then the sooner we're going to do this, the sooner we can start deprecating Erigon 1, so that we don't have to support this for a very long time. So I think if we adopt a strategy that we're making versions relatively small in scope, then we can let ourselves, free ourselves from the support of 2 old, very old versions. What do you think?
Well, we would still have to support 2 versions. The only difference is like the distance between 2 versions, and I don't know. I would make bigger releases simply because like V1 is stable, right. And if we make short releases and iterate quick, then on the one hand we can deliver the features fast. That's true, but on the other hand, well, let's just say V1 it's rock stable and it's simple. Like the state storage is simpler than what we'll have in V2, and it will be simply much easier to support than if we iterate quick. So at the end of the day, it's easier to support an older release than to support the newer release, because more bugs are fixed in V1. But if we iterate quick through V2, V3, V4, V5, then we will have basically 2 unstable releases.
Well, I think at some point, after about V2 or the V3, we were just like, it's enough. So I think you probably have a point there. But my suspicion is, even if we cut the scope of V2 short, so at the moment I'm just gonna remind myself, I included about 4 things in there, 4 main things. So what are they? So obviously I added separable consensus there as unfinished task. So second, then I added state sync. Then I added the increased granularity of the indices. And the 4th thing is the block bodies and headers. So like similar to, it's what Alexei started working on. So basically 4 things. And I say that if we do these 4 things, we do Erigon 2, basically alpha. And then maybe at that point we will have enough essentially people and infrastructure to move to better quicker than like 1.5 years. I think that one of the reasons why it took us 1.5 years, or 1 year to 3 months actually, to move from alpha to beta is still because there were lots of other things happening at the same time. So Andre?
Yeah, it's also a question of testing. Because theoretically, if you have, we have some unit tests, and probably unit test coverage is not that great. So that's one thing we can improve on. And some kind of automated integration testing, or maybe a dedicated person who runs testing and so on. Because theoretically, if all your testing is automated, then you can greatly reduce your release cycle. And when you introduce bugs, you just add a new test so that you don't repeat the same bug, and so on, and the standard engineering practice.
Yeah, so we actually started, one thing I also included in the announcement, we at least I wanted to move into this direction. So we have this QA server idea, which I think now is being reworked to use, you probably heard of something called Jenkins. Have you heard of Jenkins? Yes. So I just realized like a couple of days ago when I looked at this code, which I think Kairat has done, and it's the combination of Go and PHP and JavaScript, and you can look at it in a RPC test repository and how it looks like in the Erigon.dev website. So, but then I remembered, okay, we used to do these things with just this Jenkins thing, where you just click the button, things to start, and then it essentially what it does right now, not with the Jenkins, but with this other stuff, is that it's running some sort of background server. So you have your client application, which connects via gRPC using some certificate SSL, blah, blah, blah. But what you're doing is that, okay, you want to start a new test, RPC test, and then you specify which branch of the Erigon you want to test and which branch of the test you want to use. And it basically sends a signal to the server, and then it restarts Erigon, it restarts RPC daemon, and runs the bunch of tests, initial ones, and then just gives you a report. And then I just like, oh, but that's what Jenkins did in the past. They just click the button and it starts the test from the branch. And of course, if you do it in Jenkins, then you can do the hook from you do the hook from GitHub. And these things, I think as soon as we start building this up, I remember, Andre, you probably remember our times at one of the companies that we worked before. I actually was working on such system for good, almost a year. We actually based it on previous version of Jenkins, but a lot of my job was actually to, first of all, do the build system, which does it, but also run all the tests and everything, because I basically lived in this for at least a year. And then I just kind of and I know that once you set yourself to this and you do kind of improvement every day, like you improve these things every day, like the important bit is that we have to have something to start with, and then just keep improving and make sure that we use this stuff. And in about a few months' time, it will be amazing. I mean, if we have, because I remember the reason I actually started doing this is, and remember, Andre, now in that company, there was a policy to fire 10% of employees every year. And I didn't know about this, but so when it happened, in another round of these kind of disappearances happened, and I had the guy sitting next to me who was actually a QA engineer, and so one day he went out for lunch and he never came back to his working place. And then people told me that he's gone. He doesn't work here anymore. It's like, really? Is this how it goes? And then our first reaction is like, oh, but, and then the second guy actually who also gone at the same time was the guy who was actually in charge of this infrastructure, including these testing servers and stuff like this. And then our first reaction was like, what are we gonna do? Like we just lost the QA engineer, we lost the infrastructure guy. But then after a while, we realized we can automate most of the things that these guys are doing. So it was a bit of a pain in the beginning, but it taught, I mean, I was one of the person who picked up some of this work, and I think just dedication, and you can automate all this stuff. Yeah, so that was the story. Cool. Well, if there's no more pressing...
I have a question about the acceptance by our user base of this migration from version 1 going to beta and version 1 and version 2 coming to life, and how do they will perceive that version 1 will be some sort of long-term version instead of something that will be dropped as soon as the version 2 comes to life, comes to an alpha phase or a beta phase.
Okay, so
and also sorry, I complete the question. And also, if the effort of keeping not binary compatibility, but at least migration compatibility from 1 to 2 is possible, or we have to anticipate the user base that version 2 will be something completely new and will in the end require sync from scratch.
Okay, so a couple of things here. So I will answer both of these things. So from my point of view, one of the things that we haven't decided yet, and we will decide it only in the future, which is still upon our discretion, is this when we're going to stop Erigon 1 beta and we declare it coming out of beta. We don't know when it's going to happen. And one possibility, depending on how well the Erigon 2 is going to go, one possibility that it will never happen. It could be, I mean, you know, the multiple scenarios. So scenario 1, Erigon 2 takes a long time and blah, 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 like, and then eventually we will come to the, you know, we will see, okay, there's no issues or no major issues with Erigon 1 for a while. We think there is no new major bugs and it works pretty well, right? So in this case, we can say, fine, well, we're just going to drop the beta, right? And if we know that we have a good regression testing and we just keep chugging along, we can say, yes, that's, you know, that's ready to drop the beta. On the other hand, if the Erigon 2 goes really fast, which I think also helped by the fact that we are freezing the version 1, so that we can go faster in Erigon 2. And if we basically also due to the limited scope, Erigon 2 goes quick, we say, okay, I think we're ready for alpha. And we're going to be ready for alpha. We start doing all these migrations. And we might say, you know what, I think we're just going to do Erigon 2 beta and then release it as the thing. I don't know. We're going to make this call later on. I don't know what will happen. For the second question, whether we want to do the migration or binary compatibility, one thing I would say is that something I tried a couple of days ago, but I think it didn't quite work, but I think we can fix it, is instead of basically doing the migration, like, you know, you run some script on a database and it just produces another database, what we could do is that we run Erigon 1 as usual, and we take the Erigon 2 and we sync from that instance. So that's what I was doing a couple of days ago. I tried to sync from scratch, but not from the internet, but from my specific node.
Using a static peer.
Yeah, using just
a local static peer.
Exactly, yeah. Just pull it out of it through the static peer. And if by this time we also have BitTorrent thing, which will basically bring you as a state and blocks and stuff quite quickly. And I think it's going to be pretty easy to just, probably going to be much easier to just do that and just pull the information from your existing Erigon. So instead of running some kind of migration tool on a database, just pull it out, load stuff from the BitTorrent, and you're done. And so I wouldn't try to invest too much effort into do the migration again, because of it might be just easier to do. So if people have enough disk space to have both versions at the same time, we can just say, okay, we describe the procedure how to pull information from one to another without having to download tons of data from the internet. We might even, I mean, if we wanted to be more up to, I think it's already, the performance is pretty okay. I mean, when I tried, even when I had one single peer, I could download blocks and bodies pretty fast as I would download them from multiple peers from the internet. I think sort of the fact that my peer is local in my local area network offsets the fact that it's only one peer and not multiple. So it just basically the local bandwidth is much higher. So one peer is able to deliver me the same kind of throughput as the many peers would over the internet.
Yes, also you have to be careful in setting the source node that you're syncing from in node discovery mode, so it doesn't serve other calls from the internet, and it's basically dedicated to serving the queries coming from the syncing node only.
Oh, no, but my node did serve the other nodes in the internet. I don't know how much, but it was the node which has been running for days prior to that. And I was just another peer, but the peer who was sucking everything out, and it worked pretty well. I think.
Because I tried locally, and I saw that if I let the source node being dedicated to the syncing node is much faster.
Maybe, yeah, maybe I could do it even faster. So, but yeah, that's the. I think the sort of the breakthrough that we have already created is that the ability to sync the node from scratch in a few days. I mean, I don't know how many it is, like 3 or 4 days. It's already kind of really good for these kind of things. So you don't say to people you have to wait 1 or 2 months to do this, in a couple. And I hope with Erigon 2 the process will even be quicker. And I also hope that the footprint will be smaller. But it's good to believe in these things, right?
But also, I wanted to drop here an echo from a question that's being posted on our previous meeting in Silkwork, and maybe this goes completely out of scope, but it's intriguing to me to understand. Is it possible to imagine for the future merge a single client that manages to actually after the merge we will have basically 2 clients, the Ethereum client 2 and the working in sync with the Ethereum client 1. So 2 instances, 2 processes working together. Is it possible to imagine one single client handling the work of both?
Yes, in fact, this has been discussed a few times, and we also talked about it with Giulio today. We had the call earlier, and I told him that yes, but it's probably going to be out of scope for Erigon 2. It might be in Erigon 4 or something like this. And one thing I actually said is that, which I will repeat, is that in order to start kind of thinking about it, we need to start thinking about what building blocks we would require for this to happen. So, and obviously one of the building blocks is the libp2p or sentry, right? It's actually something that would at least allow you to start prototyping something like this. So if we had such sentry, then we would start thinking, okay, what else do we need? I mean, you can already start thinking about what else do you need but I definitely would not include it into the scope for Erigon 2.
No, I'm not saying that I expect an ETA for that, but
it is possible, and also there is a bit of I mean, depending who you ask, obviously you might remember there is a bit of a disagreement in, about what is the usefulness of something like archive node, the node which have the entire history, and also is storing it in a way that is accessible, and it's it's one thing to just store the blockchain transactions without being able to query the state. It's kind of a bit useless, but observing what was the state before. So some people think that even beacon chain, and it's not going to be very useful to have archive node. And usually it's these things are said in response to the observations that, oh, but your archive node is like 200 gigabytes or something like this, and it doesn't. And so I don't know. I mean, people who kind of responding to these questions, they make a projections about the future, which I cannot make. For example, I don't know how important the history of state will be for a beacon node, because at the moment it's pretty simple. I think because the withdrawals are, I don't think you can transfer your beacon ETH between the accounts. So the only thing that happens is the deposits some kind of rewards, some sort of slashing, and that's pretty much it. So there is no kind of transfer between accounts. So the need for history is really weak. So right, you can just look at the history on if1, and it's pretty much enough for you to understand who's got how much. And then, but the moment that the transfer is allowed in a beacon chain, I think the interest in some kind of archive node or historical access will be much higher. Because there are always people who want to know what happened in the past, right? Where is this thing come from? Like, how did the transfers happen? And then eventually, if we start intermingling with the ETH1 things, that things are becoming even more interesting. Like how these things go back and forth, and so the efficiency of representing a history is, in my personal view, the demand for such efficiency will not go away. If anything, it will become even more important. Because basically, like if you say I cannot hold 5 years of history, eventually you will say, oh, I can't hold 2 years of history because the volume of data is increased. And at which point you're gonna, okay, and then I can't hold like half a year of history, and so forth. Like if you don't improve the technology for keeping the history, eventually you will have to cut corners shorter and shorter, right? And I think it's the way we do things, and especially with Erigon 2, it's probably going to be quite useful. But I think we, at this particular moment, or maybe for next year, trying to do this will be biting too much, something that we cannot chew, as the saying goes.
One issue with archive nodes is that it requires you to keep all the old chain rules in the code. Like my hope for state sync is that, unlike full validation, it actually allows you to prune old rules of the network, like frontier rules, homestead rules, and so on. And the same for ETH2, by the way.
Mm-hmm. Well, yes, I think what the state sync allows you to do also, but I don't think it's done yet in any of the implementations, is to separate. Again, I think I really like separation, because when I see that something plays two different functions, eventually I would like to separate it, as I just discussed about the change set. So in this case, the EVM that is existed now in pretty much any implementation has two functions. One is to execute and validate the oncoming blocks, and the second is to retrace the history, but in a completely different context. When somebody wants to run the traces of something that happened 5 years ago, this is where you need all these rules, but you don't need all these rules when you're validating oncoming blocks. So if you separate these two things, then you can have an option. If somebody doesn't want to have archive node and all these old rules, they can just use the version of EVM, which is only for the latest release -1, basically. I mean, -1 because they probably, you know, if they're running the version which was released just before the hard fork, then that would be sort of two versions of the EVM. I think it's not.
But then there would be but then ideally we would have to also build 2 versions of Erigon, like one which we can be greatly simplified by removing old rules.
Yeah. I mean, that's true, and I think this is where my kind of idealistic hope is that it will be done, but potentially by different people, because basically my idealistic hope again for separating all these things is that eventually you can have multiple groups catering for multiple things. I mean, because if something like Ethereum keeps growing, the people who are supporting it in terms of development need to also grow, and the growth is only possible if you start structuring it. So if you start separating this, and I think this is totally okay for one set of people to develop the sort of the analytic capabilities that could run all the history, and for other set of people to have the EVM which is optimized for the online processing. But again, that's one of the interesting things here is that when you're aware of these possible separations and you think about a new design, I mean, for example, I really want to have a new design for EVM, and maybe once I finish some of the building blocks for Erigon 2, I will try to finish it up a little bit. So in the new design, for example, I do want to have the ability to have these things separated, to have and separated in a way that you can have, you know, 2 versions of it, to be honest.
To my mind, I'm not like personally, I'm not that bothered with all the complexity of historical EVM, because once it's coded, and it's like, it doesn't create any problems for your users. The code is pretty much stable. You don't like, once you've spent the brain cycles, you don't have to revisit it that often. What I would like to simplify is incarnations. If they disable self-destruct and then we could get rid of incarnations, I think that would be a significant simplification to the code base.
Okay, so here is actually, so one of the things that I am discovering during this Erigon 2 state sync experiment is where can we keep the incarnate, where do we have to keep the incarnation, and where we can get rid of them. And so far, it seems to me that incarnations could be deleted from these larger state files, so they are not required there, but they still need to be kept in the sort of a recent history for like within the unwind threshold. And so that is actually great news, because if we do it this way, then if there's a change that removes the possibility of, you know, self-destruct or something like this, and then we move past the possibility of that, then we can, in some version in the future, which is for mainnet, we can drop the support of incarnations altogether, because the window will move past that point.
But why can we not remove incarnations now?
Because it's a technicality question, because it's possible for, so yeah, it's something to do with having to delete the storage. So I think we had the conversation with you about this. So the problem with this is that the self-destruct is a very weird operation in both ways. So in 2 ways. So first of all, if you want to execute self-destruct on the flat storage, or actually on any storage, any way that however you store the storage in the smart contracts, self-destruct pretty much always could cost arbitrary. So the self-destruct costs fixed amount of gas, but it could produce arbitrary many computations. And so if you have a flat format, obviously, if you want to do without incarnation to delete those storages, that you can have, you need to have basically delete a lot of them. Even if you're representing your storage as a tree, and you just chop off the tree root, what you're doing is you're simply pushing this computation for later to be amortized during the garbage collection, because basically that's how the heap works. You chop off the tree, but then it has to be garbage collected in some ways. But then the other problem is the reverse operation is even worse, because if you when we do unwind, of course it happens not as often, but if you unwind the self-destruct, then if you removed all the storages, right, as a result of self-destruct, and then you unwind, now you have to bring them back, and it's even worse, right? It's like, even if you had a tree format thing, you have to somehow bring back all, like you reinsert all this data. So what we do to avoid this is basically masking. Instead of deleting the data, we're masking it with incarnations. And then after we pass the unwind limit, then we can truly delete the data, because now we know we don't have to do the reverse of the self-destruct. I don't think we can remove it now, because as I said, we can remove it as much as we can, but not completely. It's still, with the current semantics of AVM, it's still required. Otherwise, if we remove it, we basically introduce these DOS vectors. I mean, they're not going to be persistent. You cannot DOS the system persistently, but you could create kind of some spikes. I mean, I know if you look at it as the average, yes, it will be fine, because actually creating a large contract and self-destructing it, and then it costs a lot of gas. So I don't think a lot of people can sustainably do this for a long period of time.
Yeah, I mean, that's what I wanted to mention, that it's not economically feasible to actually do this for, I don't know, for more than, I don't know, what, one large contract, two large contracts, really, because there is no incentive for self-destructs now that the incentives have been, refunds have been removed. And other than that, there is, I mean, this could happen like by accident. Like, for example, there is one large contract which was used in real life, and authors decided to self-destruct it for whatever reason. But then this would be like 1 in a year or 1 in 2 years, say, situation, and it would just be one block. So I just don't feel the necessity to protect against this. Like, this is just too much security.
Right. Well, perhaps you're right. I think I mean,
we need to make this T-shirt. Erigon too much security.
Oh no, I mean, actually, I think I will try. I mean, I could try. So because today, just as I mentioned, that I realized that I need to write the change sets into the files anyway. So I'm not going to try to put them in a database, as I mentioned, in this way that. So basically, I have to write, open the file and keep writing change set. And for this, what you're suggesting is, if I were to remove the incarnations completely, what I would need to do is, in the case of self-destruct, I would have to say, okay, like I'm writing the previous values and all the new values. So basically, I have to write the entire storage of the contract out into this file. Like, okay, I write it out just in case it needed to be rolled back. And then I would write next, so, and the new value is basically empty. And it will be large. If the contract is large, it will result in this large file that, if there is a unwind, I will have to read it back again and reinsert it into the database. Maybe that's okay. And then eventually this file is just going to get deleted because the previous values are not aggregated into the state files. And that's actually the reason why we could remove the incarnations. Yeah, I can actually give it a try. So
if self-destruct will be disabled, like there is an EIP to disable it, then it's actually a pretty safe strategy, because it will only appear, like self-destruct will only appear in historical transactions for which we won't have reorgs.
Right. Okay. Yeah. I mean, I give it a try, Tom. So I think it's worth seeing what we. I mean, maybe we could then to create some kind of worst case scenario to see how bad it's going to be. Okay. Cool. Okay, anyway, so I think I'm not gonna do too much of this thing. I think I just wanted to test this live stream, and it looks like it works. And we could do them again now. So now we have a capability, and we see how how it's going. And eventually, I think we're gonna start promoting them a bit more. At some point. At the moment,
I think it was too interesting and too informative to just be a simple test. I think it's already more than that.
Yeah, sure, but I think it will be recorded. So, and if somebody wants to watch it, it's fine. But anyway, thanks everybody for coming in, and good to see you.
Just to remind you that we still have to solve the problem about. Showing on the screen the title of the people.
Oh yeah, yes. I'm just gonna write it down as my homework. Okay.
Okay.
Thanks a lot. But I think in this time, what I wanted to improve is that when I'm speaking, I can hear you interjecting, and that's what I wanted to fix, because I think it didn't really work with the Jitsi before, and it looks really weird on a recording. Anyway, have a great rest of your day. Bye bye.
Ciao.